Louise was in charge of ordering office supplies for the math department and ordered tablets, pens, and erasers, a total of 53 items. Tablets cost $4 each, pens $3 each, erasers $5 each, bringing the order to a total of $206. The sum of the number of tablets and erasers ordered is 16 less than twice the number of pens ordered. Determine the number of each item that was ordered. So this final sentence helps me as I set up a description of each unknown. The problem is asking me to determine the number of each item that was ordered. So X then is going to be the number of tablets. I'm just going to give these in the order that they show up in the problem. Y equals the number of pens. Z equals the number of erasers. So being clear on what your unknowns equal really help you set up your system. So Louise ordered a total of 53 items. So if I add the number of tablets to the number of pens to the number of erasers, that total is going to be 53. Each tablet costs $4, each pen $3, and each eraser $5, and the order total was $206. So 4x of those dollars was tablets, 3y of those $206 was pens, and 5z of the $206 came from the cost of the erasers. So when I add these three costs together, I get the $206 total. The sum of the number of tablets and erasers, so that's X plus Z, translates into equals, 16 less than means subtract 16, twice the number of pens, 2y. So let's subtract 2y from both sides, and we get X minus 2y plus Z is equal to negative 16. So this is my system of equations. What I want to do here is I want to pick a variable to eliminate first, and I'm going to choose to eliminate X first, and I'm going to use equations A and C to do that. So I'm going to do A minus equation C, or I can think of it as A plus a negative C. So I recopy A, and then I change the sign of every term of equation C. And I add. And I notice that when I do this, the x's and the z's drop out. And I'm left with 3y equals 69. When I divide both sides by 3, y is 23. So I have y right off the bat just by using two of the equations. So I'm going to choose to use A and B. Since I've already used A and C, I've got to bring B into my work. So what I'm going to do is I'm going to replace y with 23. And now when I look at equation A, it becomes x plus 23 plus z equals 53. Well, if I subtract 23 from both sides, I get x plus z equals 30. And similarly in B, I'm going to replace 3y with 69. So I get 4x plus 69 plus 5z equals 206. And when I subtract 69 from both sides of the equation. This becomes 4x plus 5z equals 137. So I have a two-variable system. Notice how careful I am to make sure I'm using all three equations. And this is going to allow me to find x and z. And I am going to choose to eliminate x first. You could just as well choose to eliminate z first in this two-variable system, two-equation system. So to eliminate x, I need to multiply equation A by -4. And I'm just going to recopy equation B. So I get -4x minus 4z equals -120. And I recopy B. And I'm able to eliminate x and find out that z, -4z plus 5z is simply z, equals 17. So now I have the value of z. And so I can use equation A to find the value of x. So I'm going to use equation A, and I'm going to replace z with 17. X plus 17 is 30. When I subtract 17 from both sides, I get x equals 13. So I have my answer, and this turned out to be a really friendly system because I was able to get to these results really quickly. So now I'm able to give the information that Louise ordered 13, and let me check back and make sure I'm remembering tablets. 23 pens, and my Z is 17, and 17 whiteboard erasers. And that's the end of the problem. In our next problem, Kadra cashed a $375 check at the bank and was given money in $5 bills, $10 bills, and $20 bills only. The teller gave Kadra a total of 40 bills, and the sum of the number of $5 and $10 bills is 7 times the number of $20 bills. How many of each type did Kadra receive? So we are going to let our variable x be the number of fives. We're going to say fives, and that's short for $5 bills. Y is the number of tens. Z is the number of 20s. So Kadra got 40 bills total. So the first equation is x plus y plus z equals 40. We're told that her check was $375 and only consisted, the money she got back only consisted of these three types of bills. So 5x of that $375 was in fives, 10y was in tens, and 20z was in 20s or $20 bills. And then we're told that the number of $5 and $10 bills, so if we add those numbers together, So if we add the number of $5 and $10 bills, that is 7 times the number of $20 bills. So is translates into equals. 7 times the number of $20 bills is 7z. And if I subtract z from both sides of that, if I subtract 7z from both sides of that equation, I get x plus y minus 7z equals 0. All right, so this is an equation. I'm going to choose to eliminate x first. And I'm going to do that by adding a to a negative c. So I'm going to change the sign of every term in c. So I get negative x minus y plus 7z equals negative 0, which is still 0. And I add. And notice I not only eliminate the x's, but I also eliminate the y. And I get 8z equals 40. If I divide both sides by 8, z is 5. So now I have z. This turns out kind of similar to what occurred in the previous problem. I've used a and c. Now I'm going to use a and b. And so in equation A, x plus y plus 5, replacing z with 5, is 40. When I subtract 5 from both sides, I get x plus y is 35. In equation B, 5x plus 10y plus 20 times 5, which is 100, equals 375. So if I subtract 100 from both sides of this equation, I get 5x plus 10y equals 275. And I'm going to choose to eliminate y first using this two-variable system which came from equations A and B. And I'm choosing to eliminate y first because I see that I'll be multiplying a by negative 10. And 10 is an easy multiplier. And that's why I'm making this choice. So I get negative 10x minus 10y is minus 350. And then I'm going to add that to equation B. And I get 5x plus 10y equals 275. I'm going to add these two equations together. The y's, of course, are going to be eliminated. And I'm left with negative 5x equals negative 75. So when I divide both sides of this equation by negative 5, x is 15. So now I've got my x and my z. And I can use equation A to find out my refined A, which is x plus y equals 35. And when I subtract 15 from both sides of this, I get that y is 20. So I have all of my values. My z is 5, my x is 15, my y is 20. So Kadra received 15 fives, or we could say $5 bills, but for short we say fives, 20 tens, and 5 20s. And that's the end of the problem.